Hello. Good evening, good evening, good evening, good evening to all the grade 12 students, the students who are writing their exams in 2024-25. Welcome, welcome, welcome. How are you all doing? How are your studies going on? About your schools and everything? Yes, nothing to panic, students. WOC, that is your World of Chemistry, is always with you all. We started this in 2017 and it's going running successfully with all your support. So, the Vani ma'am, as I said, is going to train you all for the whole academic year. We are going to follow the new examination pattern. As I discussed, the new exam pattern makes you understand the concept. The core concept understanding is important. Let us start the video without wasting time. We started with the chapter solutions. Solutions is the chapter that is the first chapter for this academic year according to the NCERT second chapter. Right. So in the previous video I did types of solutions. I kept a playlist also. Please check 2024-25 playlist is what I have already added. To that I've taught types of solutions. Now, I've been teaching expression of concentration of solutions of solids in liquids. With this, gradually I'm going topic by topic. I'm teaching the concept and I'm doing the numericals also. So I request all of you to follow me so that your 2024-25 will run smoothly. Yes, follow WOC so that all will do wonderfully. And I wanted to show you something. See this. This is an AI generated image. I used Chat GPT-4. Okay, I'm well trained in Chat GPT-4. I've done this. So please like the video, share the video, and subscribe to the channel. And tell me in the comment section how did you like this image. Comment section, please tell me whether it is good, beautifully made by AI, artificial intelligence. All right. So let us start the video. So basically, expression of concentration of solutions of solids and liquids. So basically, your concentration, what is concentration actually? So concentration is nothing, students. So basically, we are trying to express or the amount of the solute what is present, how is it present? Whether it is we're talking in terms of water, talking in terms of weight, talking in terms of parts per million in that way. So basically concentration of solutes, the one which is present in the smaller quantity, they're measured in terms of weight by weight percentage, that is mass percentage. We are studying concentration in terms by volume percentages. We are learning in terms of weight by volume percentages. We are learning in terms of molarity. Molarity. We are learning in terms of molality. We are learning in terms of parts per million, ppm. We are learning in terms of your mole fractions. We are learning in terms of normality, whatnot. And we are also learning interdependent, means in between, what is the relationship between among different factors also is what we are learning. All right. So I already did these along with the numericals. Today I'm going to deal with this topic called molality. Let us see how it goes about. First of all, what actually is molality? Okay, molality. So just to see, easy, very easy. Now, you have your test tube. Okay, in this test tube, you just have, suppose I say there's a test tube. In that test tube, I have dissolved in this 1 mole of KCl. 1 mole of KCl I have dissolved in this particular test tube, in water rather. Okay, right? This here dissolved means water. Obviously, there will be water. What do I mean by this? I mean by this means this particular thing. I'm saying 1 mole of 1 mole per kg, like this I'll write 1 mole per kg of KCl. That means 1 mole of KCl is dissolved in 1 kg of water. Okay, 1 kg of water. So in this case, what is the solvent? Water is a solvent. We are talking about this. In this case, what is a solute? KCl is a solute. So nothing. Molality is simply, it is just talking about a solute dissolved in weight of the solvent. So how do I write, or how do I define that? Molality is denoted by small m, which is equal to moles of solute, and it is divided by solvent, right? Which one? Weight of solvent. in kilogram. Weight of solvent in kilogram, right? In kilogram. So what is this now? It is denoted by, moles is denoted by WB. That is nothing but N, right? Instead of N expanding. In moles normally is denoted by N. I'm expanding that WB. This is weight of solute. MB, molecular mass of solute, and WA, weight of solvent into your 1000, because it is in kg. This is your molality. So basically, what are the units? If I have to give units, units is nothing but, just see, everything is in weight. So this whole put together, can I write it as mole? Yes, mole per kg, mole per kg, or you can write it as mole kg inverse, mole kilogram inverse, because it is coming to the numerator, so that is mole kilogram inverse. Perfect. Now this, with this units, further can I write the factors on which it depends upon? Yes, I can write. So normally, as you see, all weight, everything is weight only. Is there any volume concept? No. That means if volume is there according to Charles' law, it will be directly related to temperature. So you are going to remember, basically molality is dependent upon the mass of solvent, not on solution. Remember, depends upon weight mass of solvent, because we are talking in terms of kg, right? Yes, not on solution. Second is, it is temperature or pressure independent. Temperature or pressure independent. Remember this, because there is no volume concept. Everything is, basically we are talking about only the weight by, number of moles by weight. We are talking only about those, right? So it is mass, it depends upon the mass of the solvent, not of the solution. It is independent of temperature and pressure. This is okay. All right, now let us, with this concept, let us start solving numericals. Let us go into the numericals and understand carefully, because if you understand the concept, you can apply it in MCQs, you can apply it in, direct question answers. If they ask you in a short answer question, you can apply. If they ask you any competency based question also, that competency based question also, you can answer this question. Okay, Chalo, let us take one sum and understand. So there is one question, rather. Let me arrange my table. Okay, so there is one question. What are they asking? Question goes like this: calculate molality. They're asking you, calculate molality of which one? Of 2.5 grams, okay, of acetic acid. Acetic acid is a solute here for us, because it is present in smaller quantity. Acetic acid in 75 grams of benzene. 75 grams of benzene. Now what is benzene here? Benzene is a solvent here, because it is present in major quantity. Chal. Now for me, what is, first of all, in the solution part, I have to write what is given to me. Now we already know what is WB. WB is weight of solute. 2.5 grams is given to me. What is MB? That is molecular weight of solute, that is acetic acid. Acetic acid, it is 60 gram per mole. How to calculate this? See this, it is easy. Let me take the next page. Acetic acid is here at CH3COOH. So you consider two carbons like this, then you consider two hydrogens like this, then oxygens together. So this is 2 into 12. Yes, 4 into 1, that is molecular mass. Then your oxygen atom, 8 and 8, 16. Correct, right? It comes to 60 gram per mole. Okay, individually you're going to calculate. Okay, anything else is given? Anything else is given? Nothing. I can directly calculate now. First, for the formula, I need to calculate N by weight of solvent, right? First, I'll calculate number of moles. That is important. Number of moles, N is equal to, how much is the weight? 2.5 grams. How much is molecular weight? 60 gram per mole. So when I divide this, I get an answer around 0.4166. That is 417 mole. This is over. Now take this mole and substitute in this formula. But one more thing is there. Weight of solvent is given. How much is weight of solvent given? 75 grams. But this 75 grams should be in kg, right? So what will you do? You will come back. You will write. First of all, you will calculate weight of benzene. You have to convert this gram into kilogram. How much? 75 grams. How to convert gram into kilogram? You're going to multiply 75 into 10 raised to the minus 3. That is 1000, right? So 75 into 10 raised to the minus 3. This becomes, this is 75 gram. This is 10 raised to the minus 3 kilogram, gram inverse. So what will happen? This gram and this gram gets cancelled, and you will get 75 into 10 raised to the minus 3 kg over, substitute, molarity is equal to 0.417 mole, which we got in the earlier page, divided by 75 into 10 raised to the minus 3 kilogram. This comes to answer of around 5.56 mole per kg. That is nothing but 5.56 molar. This is the answer. Simple question. Just simply you're converting this separately. You're converting grams into weight. You're converting, your number of moles you're calculating. Shall we take one more sum? Okay, let us take one more sum and understand. If you don't know anything, please ask me in the comment section. I'm ready to answer your questions. Next question. 214.2 grams. This is a very famous question of sugar syrup, it seems. Okay, 21 sugar syrup is there. This sugar syrup, it contains, this is not this, just they said sugar syrup, it contains 34.2 grams of sugar. This is the solute now. Okay, this is the solute. What should I calculate? Calculate molality. Okay, now first of all, let us write what is there in this. So solution, what is given to us? First, given, we'll write in terms of WB only. Given WB is how much? 34.2 grams. Okay. What is your this one? So weight of, I want WA, right? So here, is anything given as WA? No. They've given sugar solution 214 grams. So here, 214.2 grams, you subtract sugar 34.2. That's all, right? So you, from the total, if you subtract, you will get automatically 180 grams. So 180 grams is weight of your mass of water. This is for water because you want weight of water solvent, but this is in grams. I have to convert this into kg, divide by 1000. So 180 divided by 1000, it your answer, you understanding, right? 180 divided by 1000. I'll leave this here. It's over. Now next I have to go and calculate number of moles, right? I have to calculate n. What is this n? WB by MB. Okay, how much is the weight given? It is 34.2 m. What is this? This is nothing but glucose, right? So what is MB now? Glucose solution. They didn't say glucose, they said sugar solution. Sugar, nothing. Molecular weight is 342.2. So when you divide, I get 0.1 mole. Okay, I got mole, I got this. I'll easily calculate. Easy, 0.1 divided by, how much did we get here? 180 by 1000. So when it goes to the numerator, 180 into 1000. I get, which is equal to molarity almost 0.555 molar. Easy, easy, very easy. Next sum, shall we see one more sum, one more variety? Alright, let us check one more variety. Question is what I'm giving. Check. A solution, this is one more famous sum. Solution contains, gradually we will write 410.3 grams of sulfuric acid. It contains 410.3 grams of sulfuric acid per liter. Okay, per liter it seems. Per liter of which one? Of solution. They've given one more thing is temperature at 20 degrees centigrade. At 20 degrees centigrade. Now here they've given one more concept. If density is 1.24 gram per ml, what will be molality and molarity? They're asking you both the things in this. Let us do it easy only. There's nothing big. Let us solve it easily. So let us divide the page into two things. One is for molarity and one, as I'm just drawing a line. so that it's easy for you to understand. First thing, molarity formula is WB by MB into volume of solution in liter. We did in last video about molarity, right? In liter. What is molality? M is equal to WB by MB into WA, weight in kg. Correct, right? This is in liter, this is in kg. Now let us write what is WB given to me. Sulfuric acid 410.3 grams. What is MB of sulfuric acid molecular weight? It is 98 gram per mole. Correct. What is the volume given to me? 1 liter is the volume given to me. Easy, right? I can easily calculate. Sure. Weight by molecular weight 410.3 gram divided by 98 gram per mole. Correct. When I divide this, I get almost 4.186. Okay. So molarity is equal to, I have to divide by volume also. 186 divided by 1 liter volume, which is equal to 4.186 molar. This is molarity. Over. Now, I'll come back to this. Already we have calculated this part. I got here 4.186, right? So, can I use that? Yes, I'll use that for molarity. Then, okay. 4.186. Okay. Then divided by what is this one? Weight of water in kg? That I don't know, right? I don't know about WA. I don't know about WA. What is this? How to do this? Now let us do. First of all, they said it is dissolved in 1 liter solution. That is what they have given, right? So now what will I do? I will write mass of 1 liter sulfuric acid. Mass of 1 liter sulfuric acid. How much is 1 liter sulfuric acid solution? How much is this? 1000. Yeah, here they've given density. So what will I do? Mass I am to find by multiplying into density into 1.243 gram per ml. When I multiply this, this is ml and that is also ml, that both gets cancelled and grams is left. That is 1243 grams. This is okay. Mass of 1 liter of sulfuric acid. Now this 1 liter has water, so I have to get mass of water, right? So mass of water is how much? Mass of water is just it. Here I got 1243 grams. Here sulfuric acid mass is 410 grams. So subtract both of them. 1243 minus 410.3. This comes to 837.2 grams of 832.7 grams of this is the mass of solvent. Over, right? So substitute in the formula. This one is equal to 4.186. This is the mole weight. 837.2 into 1000. So when I multiply, I'll be getting an answer of 8 around 5, right? 4. Okay, I'll be getting 5.027. Check this calculation. So the answer is yes, 5. Okay, let me write again here. So the answer is 5.027 molar. This is the answer. Easy, very easy. So the density is given to you. You can calculate in that terms so that you can directly get the answer. Let us do one more question. One more related to density only, but important. Let's see. One more question, what we are going to learn is, let us see here. The question given to me is the density of 2.03 molar solution of acetic acid. One acetic acid solution is there, it seems. Okay, even acetic acid molecular weight, that is MB weight, is 60 gram per mole. This already we know. Better we write it first only. Okay, mole. In water. In water. So the water is a solvent here is 1.017 gram per ml. 0.17 gram per ml. They're asking me to calculate molality. Calculate molality. Calculate molality. Okay, molality. Let us take first what is given. Given data. What is given data to me? Let us write all the given data. First of all, they said molarity is given to me, 2.03 molarity. Okay, mb is given to me, that is 60 gram per mole. Density is given to me, that is 1.017 gram per ml. This is done. This is done. Okay, now what should I calculate? I calculate molality. So molarity and molality, how to do it? Simple formula. First calculate strength of the solution. Why strength of the solution? Because strength of the solution. Here, the molarity is nothing but the strength, right? So, strength of the solution is nothing but molarity into molar mass. Okay. How much is molarity given to me? 2.03. What is the molar mass of acetic acid? 60 gram per mole. Correct, right? So, when I multiply 6 to the 12, so it comes to 121.8 gram. Correct? Gram per liter, because this is 2.03 molar, 60 gram per mole. Okay. This is done. All right. So, gram per mole. Okay, 21 strength, gram per mole. Sorry, mole, not liter, mole. Okay, this is done. Now, how much is density given? Density given to me is 1.107 gram per mole. So, I have to calculate molality, correct? So, this is density. Now, check. What am I doing? I am taking mass of 1 liter of solution. Density is equal to mass by volume, right? So, mass is equal to, it is right, density is equal to mass by volume. Mass is equal to density into volume, correct? So, how much is density? Volume is 1000 ml. Volume is 1000 ml into density is 1.17 gram per ml. So, if I multiply this, I am getting simple grams. This is over. Now, I've got mass. So, but still I didn't get, this is of the acetic acid, but I still need to get water mass, because that is where we are going to do it in molality, right? So what we are going to do now, we are going to calculate the mass of water. I want the mass of water in which unit? I want the mass of water in kg. Mass of water is equal to, this is an acetic acid. So 1017 is the solution weight. Then acetic acid is 121.8. Correct? We have already got the strength of the solution. So we subtract it and you'll be getting around 895.2 grams. This is in grams. Now you're going to convert this 895.2 grams divided by 1000. So this comes in kg. Now keep all the data ready. Now let us substitute in the molarity part. Molarity part. Molality is equal to, so 2.03, which is already given, which is already given in terms of molarity, divided by your mass of water is 895.2 into 1000. That's 895.2, and this is 2.267. This is the answer. Okay, chalo, yes, done. Oh, perfect. So this is one more variety of sum which you should practice for the molality. Be careful. Any doubt, you please ask me in the comment section. I'll surely let you know. Let us do one more sum. With this, I think the concept of molality will be covered. One more question. Okay. Let us take one more question. A solution is prepared. The solution is prepared by dissolving 5.64 grams of glucose. Okay, there's one solution which is prepared by dissolving 5.64 grams of glucose. In which one? In water only they have to dissolve, right? It means glucose, water, or any solvent. There's 60 grams of water. Calculate two things they've asked here. Mass percentage of each. Mass percentage of each means both of glucose and water. Second, calculate molality of solution. Molality. Perfect. So let us take this sum and do it. Mass percentage we already did. Correct? Mass percentage of each they asked. Wait. You have to be careful. weight by the total weight. So first of all, let us calculate the mass percentage. Total mass of solution. Total mass of solution. What is the total mass of solution? They've given me two. One is 5.64, one is 60. Total add 5.64 plus 60. How much is this? 60, 65.64 grams. 65.64 grams. This is total. Now they asked me to calculate individually, right? Mass percentage of glucose. How much is mass percentage of glucose? It is weight by the total weight. How much is weight? 5.64 divided by 65.64 into 100. This is mass percentage, right? Which is equal to 8.59%, which I calculated and kept it. Same, I have to do it for water. Yes. Mass percentage of water. How much is weight of water? It is, I should do the same way? No. I can do 100 minus mass percentage of glucose I can do, because the remaining part is water only, right? Mass percentage of glucose. When I do this, I get 100 minus 8.59, which is equal to 91, right? Yeah, 91.41 percentage. That's all. This is mass percentage. Easy, both. Now I have to calculate molality, correct? So to go back again, write the formula. Molality is equal to WB of the solute, MB of the solute, WA of the solvent into 1000. Correct? Okay. So how much is WB by MB? Did they give me? Yes, because they said 5.64 grams, they said, right? So I will write how much is 64 of glucose, they said. So 180 grams. How much is the weight? 60 grams is the weight. That is what they said. 60 grams of water. So 60 into 1000. That's all. When I divide, I got an answer of 0.522. So this is the answer. 0.522 molar is the answer. Easy? Very easy. So with this, we have covered all the concepts related to molarity. So students, I request you to please, if you want, please note it. And I request you to please again like the video, share the video so that it gives support to Vani ma'am. Vani ma'am will be uploading the videos for your 2024-25 responsibility is mine. So please stay connected. Thank you so much, students. Thank you for watching. I request all of you to stay happy always. Keep smiling always. Bye-bye. Thank you.